Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 5 to the power of x plus 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 5 to the power of x is equal to 2. Now, because our left-hand side here has all our terms being 5 to the power of x, what I'm going to do is I'm going to factor out 5 to the power of x from our left-hand side. So by doing that, I get 5 to the power of x times 5 to the power of x divided by 5 to the power of x is 1 plus, same thing again, they're the same terms, 1 plus 1 plus 1 plus 1. Now, we want to simplify what's in the parentheses. So 1 plus 1 plus 1 plus 1 plus 1, that's going to be 5. So now we have 5 to the power of x times 5. And remember, this is equal to 2. Now, we want to isolate x, so I'm going to divide both sides by 5. These two cancel out for our left-hand side here. So for our left-hand side, we have 5 to the power of x. Now, this is equal to 2 over 5. Now what I'm going to do is I'm going to take the log of both sides. So now we have log 5 to the power of x is equal to log 2 over 5. Now, an important property of logarithms is that if we have something in the form log a to the power of b, the power property of logarithms states that we can actually move this exponent b to the front of the logarithm. So this would actually equal b times log a. So in this case, we have log 5 to the power of x, and I can actually move this exponent x to the front of the logarithm. So this would equal x times log 5 is equal to log 2 over 5. Now, another property of logarithms is that if we have a log of a fraction, let's say log a over b, this would actually equal the log of the numerator minus the log of the denominator. So log a minus log b. So we can do the same thing to log 2 over 5. So this is going to be x times log 5 is equal to log 2 minus log 5. Now I'm going to divide both sides by log 5. So now we get x is equal to log 2 minus log 5 over log 5. Now, the value of log 2, this is approximately equal to 0.3 3, 0, 1, 0. And log 5 is approximately 0.6990. So now if we plug these values in, we get x is equal to 0.301 minus 0.699 over 0.699, and this means that x is equal to negative 0.5694. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 7 to the power of x plus 8 is equal to 8 to the power of x plus 7. Now, if we have something in the form a to the power of n plus m, this is equal to a to the power of n times a to the power of m. So as you can show you right here, we have 7 to the power of x plus 8. This is going to equal 7 to the power of x times 7 to the power of 8. And now this is equal to 8 to the power of x plus 7 is equal to 8 to the power of x times 8 to the power of 7. Now I'm going to divide both sides by 7 to the power of 8 as well as 8 to the power of x. So these two would cancel out, and on this side these two would cancel out. So now we are left with 7 to the power of x over 8 to the power of x is equal to 8 to the power of 7 over 7 to the power of 8. Now 7 to the power of x over 8 to the power of x is the same thing as 7 over 8 to the power of x, and now this is equal to 8 to the power of 7 over 7 to the power of 8. Now I'm going to take the log on both sides, so now we have log of 7 over 8 to the power of x is equal to log 8 to the power of 7 over 7 to the power of 8. And the power property of logarithms states that if we have a power for the logarithm, which in this case is x, we can actually move this to the front of the logarithm. So now this is actually going to be equal to x times log 7 over 8. And if we have something in the form log a over b, this is equal to log a minus log b. So log 7 over 8, this is going to equal x times log 7 minus log 8. Now this is equal to log 8 to the power of 7 minus log 7 to the power of 8. Now I'm going to divide both sides by log 7 minus log 8. So now these two cancel out, and we are left with x is equal to 7 log 8 minus 8 log 7, because remember, we're moving the exponent to the front of the logarithm, over log 7 minus log 8. Now, log 7 is actually equal to approximately 0.8451. And log 8, this is equal to approximately 0.9031. So if we plug these values in for x, we get x is equal to 7.5707. So this is our answer. And we can also write it like this. Doesn't really matter. But yeah, that's our answer.